how do we graph lines that say y equals 2 or x equals -3? What exactly do those look like? Well, we're still going to follow the same steps to figure out how to graph these. In my example 3 here, it has y equals 2. So I'm going to rewrite this in slope-intercept form. That's just like y equals, if x is gone, that means that 0 must have been multiplied to it in order for it to appear gone. So I'm going to rewrite it as y equals 0x plus 2. From there I can see my slope is 0, my y-intercept is 2. So I'm going to go to my y-intercept at positive 2. My slope is 0. What does that mean, 0? 0 could be 0 over anything. It could be 0 over 1. It could be 0 over 5. It doesn't matter. I'm going to go up 0 over however many I want. Up 0 over however many I want. Up 0. Could even go negative however many I want. No matter how many I go over, I'm going to be going up nothing. So really I'm just staying here right on this 2 line where y is always 2. If x is 5, y is 2. If x is 9, y is 2. If x is -8, y is 2. Doesn't matter what value I put for x, my y is going to always be 2. And I can see that I have a 0 slope, which is confirmed by my equation. Great. So maybe my left side question would be, what does a y equals 2 graph look like? And if I was studying, I would be able to cover my notes up, ask myself my left side questions, and say, what does a y equals 2 graph look like? Oh, looks like a horizontal line going through y equals 2. Yep, it sure does. How about this one? How about, let's see, what does, let's make this a capital W. Sorry, I'm trying to look through my screen instead of on the paper. What does x equals -3 graph? What does a x equals -3 graph look like? We'll be able to answer that now. Well, here, oh boy, this is kind of a mess. This is not actually a function, so we can't really write this in slope-intercept form. So really, our only choice is to think about it. If x equals -3, so let me go to my x and put it at -3. Doesn't matter what y is, x is going to equal -3. So I could think about any points that I want. If x is -3, y could be 5. If x is -3, y could be -5. If x is -3, y could be, I don't know, 2. Really any number. Let's go ahead and graph these. X is -3. We got y is 5. X is -3. Y is -5. X is -3. Y is 2. It could really be any value. X is always going to be over here on this -3, and y gets to move. This is where we have, remember, undefined slope, whereas this one was a 0 slope. Oops, sorry, got lost. So this doesn't really apply here. Our slope is undefined. Where does it cross the y-axis? Where does it cross the y-axis? Actually, never. It only crosses the x-axis. It never crosses the y-axis. It never intercepts with that y-axis. All right, a few more little tiny examples. What happens if we're given a graph and we want to write the equation? Well, I can always start by saying identify my slope, identify my y-intercept. Right here, my y-intercept is 2. My slope is up 2 over 1, 2, 3, 4, 5. Not bad. Oops. Up 2 over 5. So my equation is y equals 2/5 x plus 2. How about this one? My y-intercept is -1. My slope down 1 to the right 4. Down 1 to the right 4. So I get y equals negative 1/4 x minus 1. And lastly, over here I have a horizontal line. I know it's a 0 slope at negative 2. Y equals 0 x minus 2, or in other words, y equals negative 2. All right, make sure you leave space for your summary. Some things that you might want to summarize are what are the steps to graphing lines? What do you do if it's not in slope-intercept form? And what do graphs look like if you have a 0 slope or an undefined slope? Those are some of the things you want to touch on over here in your summary. All right, now it's time to go ahead and work on today's practice. You have, let's see, you have 10 problems. If you finish them all, you have no homework. Good luck.